So this is the working out of the problems for the review for the test on Tuesday. The first problem is a right triangle, so we're going to solve it with the Pythagorean theorem. Leg squared plus the other leg squared equals the hypotenuse squared. So we get 100 plus 49 equals x squared, 149 equals x squared. And then we're going to take the square root of both sides, but we are only going to keep the positive answer since this is a length, so the square root of 149. You can approximate it if you want, but there is no need. For number 2, a cost function, we have to figure out the fixed cost plus the variable cost. So from this problem, the fixed cost is the initial investment, $2,000. And the variable cost is what it costs to make each unit, $4.50. So we have to add on $4.50 for every unit that we make. And that's what X always stands for, the number of units. Revenue, we're going to do the price times the number of units we make. So in this case, the price is $12.60 times X units. For profit, which is capital P, it's revenue minus cost. So we're going to take our 12.6x minus all of our cost. So the $2,000 and the 4.5x. We're going to subtract both of them by distributing. 12.6x minus 4.5x is 8.1x minus 2,000. That's our profit function. Average cost per unit means that you take the cost function and you divide it by the number of units you make. So in this case, that's the 2,000 plus 4.5x, all divided by x. In order to find break even, that's when revenue equals cost. So you would want to set your 2,000 plus 4.5x equal to your 12.6x. Subtract 4.5x from both sides. Divide 2,000 by 8.1 and get 246.9. But remember, x is a number of units, so you need to round it to 247 units. In order to write it as a point, you need to put the 247 as your x value and plug it back in to either revenue or cost and to get your y value. So the easiest place to plug it in is revenue. So I'm going to take 247 times 12.6 and get $312.20. That is the point that you need to give as your answer. Number 3 is how to write a linear equation. Sorry, technical difficulties. In order to write a linear equation, you have to come up with 2 points. So if the stock is increasing in value from the original price of $12, we can write the first point as 0, 12. The money is always your y value. And in this case, the year, which is 0, is my t value or my x value. So I am got 1.012, and the next point is $26 over the course of 3 years. So it's increasing to $26. That's my y value. And my new time is 3 years. So I've got 2 points. I'm going to write the equation of the line by coming up with the slope, subtract my y values over subtract my x values, and I end up with 14 over 3, or 4 2/3. So that's my slope. When I go to write my equation of my line, the easiest way to do it is y equals mx plus b, because I have b. B is my y-intercept, and that's what this point is. So I can say y, which is my value, equals 4 2/3. Instead of using x, the problem told me to use t, so I'll call it t plus 12. 12 being my y-intercept. And there's my equation of my line. For number 4, to write y as a function of x, we need to solve this equation for y, which means we're going to keep the 2y where it is. We're going to subtract x squared from both sides, and we're going to add 5 to both sides. So the x squared moves over as a negative. I'm adding 5 to 7 and getting 12. The last step I have to do is divide everything by 2. So I have negative 1/2 x squared plus 6 is equal to y. Y as a function of x. For B, x as a function of y, we need to rewrite this because right now y is the function of x. So we need to switch the x and the y. The easiest way to do this when you have a fraction on one side is to imagine a fraction on the other side and to switch on the diagonal. So you can take the y and put it where the 2 plus x was, and take the 2 plus x and put it where the y is. You can always do that with a fraction. If you imagine two fractions you know are equal and you flip on the diagonal, you still get an equal statement. Or if you flip on the other diagonal, you'll always get an equal statement anytime you do that. So it's equivalent, it's true that 2 plus x is equal to 5 over y if I switch these two. So now that I've done that, I need x as a function of y. The only thing I have to do is subtract 2 from both sides. And now I have x as a function of y. To write an absolute value as a piecewise function, we talked about this a lot. We want to figure out where the pieces break apart. That's where 2x minus 5 is 0, or where 2x is 5, or where x is 5/2. So we say that this function is 2x minus 5 if x is greater than or equal to 5/2, or the exact opposite if x is less than 5/2. That's rewriting an absolute value as a piecewise function, and you may have to do this when you're figuring out limits or continuity. To find an equilibrium point, you set supply equal to demand. So you're going to set your 200 minus 5x equal to your 2x plus 12. You're going to add 5x to both sides, subtract 12 from both sides, and then divide. Again, when you end up dividing here, you're going to get a decimal answer, 26.857. You want to round that up to 27 units. Then you're going to write your equilibrium point, because it's a point, as 27 comma, and you're going to plug your 27 either into the demand function or the supply function, either one. So I'm going to plug it into demand, 2 times 27 plus 12, and get 66. You'll get a slightly different answer if you plug it into the other function, but either one is fine. The difference quotient. You should know the difference quotient is, no, not that, f of x plus h minus f of x all over h. So for each of these functions, setting up the difference quotient and simplifying it will have a little different twist to it. For the first one, you're plugging x plus h in where x is. So this is x plus h squared minus 2. That's f of x plus h. Minus f of x, which is the function that I gave you, x squared minus 2, all over h. So again, you're taking x plus h, you're sticking it in where x is, and doing whatever is being done to x, which is squaring it and subtracting 2. Then you do the same thing for f of x. Subtract those two, which is why it's called the difference quotient. To simplify this, you have to expand out x plus h squared, which means you have to FOIL it. X squared plus 2xh plus h squared is what you get when you take x plus h times itself and you FOIL. We have the minus 2 from here, and then we have to be very careful to distribute our other minus through the parentheses. Minus x squared plus 2 all over h. If you do this correctly, any terms that do not have an h in the numerator will add to 0, like this x squared and that negative x squared, this negative 2 and that positive 2. So what's left in the numerator, both terms will have an h. You're going to factor it out so that you can divide it out with the h on the bottom. And the final answer is 2x plus h. For b, when we plug into the difference quotient, we're going to put x plus h into this function. So it's going to be the square root of x plus h plus 5 minus the function just as it is, the square root of x plus 5, all over h. To simplify this difference quotient, we're going to use the conjugate. So we're going to multiply and rationalize the numerator, multiplying x plus h plus 5 plus the square root of x plus 5. So it's the same radicals with addition in between instead of subtraction. And we're putting it over itself so that we're just multiplying by the number 1. And what this does is when you multiply the square root of x plus h plus 5 times itself, you get x plus h plus 5. When you multiply the negative square root of x plus 5 times the positive square root of x plus 5, you get minus x plus 5. And on the denominator, you'll have your h from here and your conjugate. But what's going to happen again in your numerator is you're going to distribute your negative through, and x minus x will be 0, and 5 minus 5 will be 0, so the only thing left will be h. So you'll have an h on top and an h on the bottom. And since the h on the bottom is connected to the conjugate by multiplication, you can divide them out. And your final answer is 1 over the square root of x plus h plus 5 plus the square root of x plus 5. That's the difference quotient for this function, simplified. And then finally, the difference quotient for a fraction. You're going to put x plus h into your function, so it'll be 1 over x plus h minus 1 over x all over h. So we're evaluating the function at x plus h, we're evaluating the function at x, and we're putting it all over h. In this case, we need a common denominator. So in our numerator, the denominator will be x plus h times x. And so this first fraction, its new numerator will be x minus this fraction's new numerator will be x plus h in parentheses. And it's all over the same h. So at this point, we can distribute our negative through, and x minus x will be 0, but we'll still have a negative h on top. We have our x plus h and our x, and it's all over h. So we have our 3-story building. We're going to collapse the 2 bottom stories together so that we have h, x plus h, and x. And finally, this h and that h can divide each other out, which always happens on a difference quotient. And we're left with negative 1 over x plus h times x. Limits. Remember, for limits, the first thing you want to do is try to plug in the value you're approaching and see if that's is all you have to do for the problem. So if I plug a 4 in here and I plug that same 4 in for x, my limit is going to be 16 minus 6, or 10 over 4, which is 5/2. If I try to do that on b, and I put the 2 in, I'm going to get 4 minus 4, which is 0 on top, and 2 minus 2, which is 0 on the bottom. Whenever I get 0 over 0, that means that I need to do more work. I don't know what the limit is yet. So the work that I can do on this problem, hopefully you see that you can factor the top, and there'll be a factor in the top, x minus 2, that can divide out with a factor on the bottom, 2 minus x. These two are exact opposites of each other, so when I divide them out, I create a -1. And so what I'm really taking the limit of as x approaches 2 is -1 times x plus 2. Once these two factors are divided out, now I can plug my 2 in again and get -2 plus 2, or -4 as my limit. For C, this is the time when you have to take an absolute value and rewrite it as a piecewise function. So again, I have to say that these two functions break apart when what's inside is 0, or x is 3. So this function is x minus 3 if x is greater than or equal to 3, but it is the opposite of x minus 3 if x is less than 3. In order to take a limit as x approaches 3, because that's where my function breaks apart, I have to take the limit as I approach 3 from the left and the limit as I approach 3 from the right, and see if I get the same thing. When I approach 3 from the left, I'm on the piece where x is less than 3, because this is where I'm coming in from the left. So I'm plugging into the opposite of x minus 3. When I approach from the right, I have to pick the piece where my values are greater than 3. So I'm coming in from the right of 3, and that's the function x minus 3. If I plug what I'm approaching into my function now, I get -0, which is 0. And here I get +0, which is also 0. So when these two match, I say the limit as I approach 3 on this function I was talking about is 0, because these matched. If they didn't match, I would say the limit does not exist. For D, if I try to plug the 4 in and I get 5 over 4 minus 4, or 5 over 0, that means the limit does not exist. 0 over 0 does not mean that, but any other number over 0 means the limit does not exist. If I'm trying to talk about the continuity of a function, for this function, less than or equal to 2, so from -infinity all the way to 2, it's a rational function, a function under a radical. And for all of those values, when I plug any value up to the number 2, and I'm under the radical, I can say that this function is continuous. Sorry, this should have been the other way. This should have been x is greater than 2, and this should have been x is less than or equal to 2. Or else I won't be in my domain. So, back up. For any value from 2 on to infinity, if you put those numbers into this radical, you will find an answer. So this is continuous on this interval from 2 to infinity. Radical functions are continuous on their domain. From -infinity to 2, when we're on this piece, this is a polynomial. Polynomials are continuous on their domain. But I have to check at the point 2. in order to see whether these two whether this entire function is continuous. I have a radical function meeting a linear function, a line. Sometimes those two things meet at the same point, and then that we're continuous along the whole number line. Sometimes those two functions don't meet at the same point, and that's what I have to check when x is 2. So the way I do it is I do the limit as x approaches 2 from the left, and I want to be on the piece that is to the left of 2, where x is less than 2. So that'd be negative 3x plus 8. And see if that equals the limit as x approaches 2 from the right. So I'm on the other piece. In order to calculate these limits, I'm just going to plug the number 2 into this function and get negative 6 plus 8, which is 2. I'm going to plug the number 2 into this function, which is 6 minus 2, which is the square root of 4, which is also 2. Since my limits match, the limit as x approaches 2 on my function is 2, and this function is continuous on negative infinity to infinity. I knew it was continuous up to 2, I knew it was continuous after 2, but because the limits match, and they match the function value, which is also negative 6 plus 8, then I say it's continuous on the entire number line. So I should squeeze in here that the function value at 2 is also 2. So to talk about continuity on a piecewise function, you need to talk about each piece and where they come together. Finally, x and y intercepts. To find the x-intercept, you set y equal to 0 and solve for x. To find the x-intercept, you set x, or to find the x-intercept, you set y equal to 0 and solve for x. To find the y-intercept, you set x equal to 0 and solve for y. So for the x-intercept, and I set y equal to 0, this term will be 0, and this term will be 0. Both the terms that have a y in them, when you plug 0 in, will go to 0. So I'll have 2x squared equals 32. Solving that, I divide both sides by 2 to isolate my x squared. I take the square root of both sides, and this time I have to remember my plus or minus, because this is not a length. I'm going to have an intercept of 4, 0 and negative 4, 0. For my y-intercepts, when I set x equal to 0, this term will go to 0 again, but so will this one. And I'll be left with negative 5y equals 32. I'm going to divide both sides by 5, negative 5, and there's my y-intercept, 0, negative 32. Just one y-intercept because y wasn't squared, 2 x-intercepts because x was squared. So that's the review sheet. Please feel free to email me or text me if you have extra questions. Otherwise, I will see you on Tuesday for the test.